Hi, and welcome to a video on how to evaluate definite integrals that involve a u-substitution. This is the second video in a 3-video series, so if you haven't seen the first one, you want to watch that first. And if you're not familiar with the technique of u-substitution, you want to make sure you know how to do that before you watch this video. In this video, we're going to do the problem, the integral from 0 to 1 of x over x squared minus 4 dx. Now remember, whenever you're doing integrals, you want to first see if you recognize the antiderivative of the integrand. There might be some things this reminds you of, but I don't think there is a function that we can easily think of off the top of our heads that yields this as its derivative. So let's think about what a good u-substitution would be. When you do u-substitutions, you want to look for a function derivative relationship. And if I look at the denominator here, the derivative of x squared is 2x. And since I have an x here, I can generate the 2 because it's a constant. So let's let our u be the denominator. So we're going to let u be x squared minus 4, which would give us a du of 2x dx. The x dx is right here. So we're going to put that 2 on the other side. We can replace the x dx with a 1/2 and a du. I'm going to put the integral right here, so factor out that 1/2. And then the x squared minus 4 is our u, so I have 1 over u du. Now remember, these limits of integration right now, they're x's. If we want to change everything into u, I need to figure out what they would be as u's. In order to do that, we're going to take and we're going to plug them in for x. So if I take 0 squared minus 4, I get a negative 4 here. And if I take 1 squared minus 4, I get a negative 3 here. So essentially, let me clean this up a little bit. We get the 1/2 of the integral from negative 4 to negative 3 of 1 over u du. Okay, now this is one we should know right off the bat. The antiderivative of 1 over u is the natural log of the absolute value of u. So we end up with 1/2 natural log of the absolute value of u evaluated from negative 4 to negative 3. And at this point, it's just a matter of plugging things in and evaluating the integral, or the result. So let's go ahead and do that. Be careful. Make sure that you don't make any arithmetic mistakes. Okay, and for this problem, you want to use some properties of natural logarithms to simplify a bit so you get a nice clean answer that is one term. So this example is a little bit different than the first one, just to give you some variety and see how you have to deal with things like natural logs. There's one more example, so be sure to watch that before you proceed with your assignment.